Okay, Assalamualaikum warahmatullahi wabarakatuh. We are from group 61. My name is Ardian Ahnaf and my partner is Fatimah Naya. And today I'm going to present my project about automatic weather monitoring system. So, for the introduction for our project, that in an era where climate and weather patterns are increasingly unpredictable, the need for accessible and accurate weather monitoring systems has never been more critical. We proudly introduce our latest project, an advanced Arduino-based weather monitoring system. And for the background, as cities around the world become increasingly populated, the demand for smart technology solutions to enhance urban living and environmental management has risen. And smart cities use technology and data to improve the efficiency of urban services, enhance quality of life, and reduce environmental impact. In this context, real-time weather monitoring systems becomes crucial, whereas it helps city planners, residents, and businesses adapt to changing environmental conditions promptly.
Okay, now I'm going to explain the components we use to build our project. First, here we have Arduino Uno. This is kind of like the brain of our system because the Arduino is the one who controls everything and processes the data collected by the sensors. It's like the command center, taking in information and deciding what to do with it. Next, we have rain sensor. This sensor detects rain, and this sensing pad acts as a variable resistor whose resistance varies according to the amount of water on its surface. Next, we have DHT11 sensor. This is a temperature and humidity sensor. It measures the air's temperature and how much moisture is in it, and the DHT11 sends this information to the Arduino Uno. Next, we have micro SD card reader module. This module allows our system to save data. The Arduino sends the data it collects from the rain sensor and DHT11 to the micro SD card. Next, we have application, where we have a range of practical and beneficial uses, especially within the context of smart cities. First, we have smart city infrastructure. The system can provide valuable data for city planners to design infrastructure resilient to local weather patterns. Real-time weather data may also help in predicting and managing natural disasters like floods, leading to better preparedness and response. Next, we have agriculture. Farmers can use weather data to make informed decisions about irrigation, planning, and harvesting. Also, certain weather conditions promote the spread of pests and diseases. Early warnings can help in taking preventive measures. Lastly, we have smart home systems, where our project can be connected to smart home systems to automate actions like closing windows or adjusting thermostats based on weather condition. Last but not least, we have our schematics. If I'm going to simply explain our project, it's going to be the Arduino constantly reads data from the rain sensor and the DHT11, and when it detects rain or when the panel is wet, the temperature and humidity will change, and it records this information, and the SD card module keeps a log of all this data so we can review it later. And so here is the code used for running our project. Let's have a quick look by starting at the beginning of our code. So here, first, we include the necessary libraries for our sensors and the SD card, and we define constraints for our DHT sensor pin, sensor type, rain sensor pin, and the file name for our data file. Next, in the setup function, we initialize our serial communication, the DHT sensor, and check if the SD card is working properly. Notice how we create a file on the SD card to store our weather data with headers for time, temperature, humidity, and rain value. And in the loop function, the system pauses briefly to stabilize the sensors. We then read the temperature, humidity, and rain sensor values and print them to the serial monitor for real-time viewing. And the most crucial part here is logging the data onto the SD card. Each data point, along with the current time in milliseconds, is appended to our file. So this allows us to track weather patterns over time. And lastly, this is our error handling. This ensures our system runs smoothly and alerts us if something goes wrong.
So this is our simulation for the project. As you can see in the circuit, we use Arduino, we use rain sensor, the DHT11 SD card, then the LED. So let's just begin our simulation by pouring the water to the rain sensor. And when the rain sensor is wet or it is raining, the LED will turns on and it shows that it is raining right now. And the DHT11 or the temperature and humidity sensor will shows us the temperature at the moment and the humidity at the moment. So when we upload the code to the Arduino or we run the project, the first one is the SD card will initialize and it will shown us the temperature, humidity, and the rain value. And in this section where the rain value is above 500, that means that it is not raining at the moment. And when it goes to below 500, it will tell us that it is raining and the LED will turn on. And this project, in this code, it will loop and print out the values every 10 seconds, and all those values will be saved in the SD card that we already put. And we use data logging tool for data logging also for the SD card.
Now we're moving to the last section, which were data logging section. So here first we have to remove our micro SD from the module and insert it to the reader connected to our laptop. Then this step might be different depending on what laptop you use, but basically we just have to find the file, and here we found the text file from the micro SD card, and there is our data showing the temperature, humidity, and rain analog value. Rain value here just represent the resistance of the rain sensor board, which the more water on the surface means better conductivity and will result in a lower resistance. That's why when the panel is dry, you can see here it has over 1000 in resistance value, and the wetter it gets, the lower the value, which means lower resistance.